Hey guys, welcome back to the Philco 90 restoration project. At the end of the previous installment, we finished rebuilding the AC line bypass capacitor, which also serves as a return path for the RF to ground. That includes the antenna. Rebuilding that, installing it, made a huge difference on reception. We've now got we're now receiving a lot more stations, and some of them are booming, some of them are pretty good. So where do we go from here? A lot of things we can work on, a lot of little things. But one I'd like to address is how much the sound volume changed from station to station. This radio does have a feature known as AVC, Automatic Volume Control, or AGC, Automatic Gain Control. How does that work? It takes a portion of the received signal and uses that to bias some tubes on the front end, thereby changing their gain. The idea being, if you get a weak signal, it tries to boost the gain to make it louder. Or conversely, if it's a really loud signal, cut down the gain so it's not quite so loud. Some early radios, in fact the first version of this radio, didn't have a AVC, which meant every time you tuned in a different station you'd have to go over and change the volume. Which is another issue on this, is that this is not the original volume control, nor is it the original on our spare parts donor chassis. Now, it's not really surprising that on a lot of antique radios, the volume control has been replaced because it sees a lot of action. People are constantly adjusting the volume. Problem with this one is, one, I don't know if it's the right value. Two, it doesn't seem to really work right. Now, it's supposed to be 500K, which is a pretty common value, but it's also supposed to be audio taper. What does that mean? It means the resistance changes logarithmically as you rotate the control rather than linearly. That's because our ears work logarithmically. If you use a linear control, what happens is the volume does not change much for most of the travel of the control, and it's all bunched up at one end. So that's kind of how this volume control is working, but also when it's all the way down, we still get quite a bit of sound coming through. Alright, well, I started looking through my stash of controls, and I'm not having much luck so far. These are the only ones I've found that are close. The two with the long shafts are 350K, and this dual one are 700K. Probably both are close enough, but none of them are audio taper. But at least I might try tacking one of these in just to see what effect it has. The knobs I have won't fit on either one of these shafts, but I can turn this with my fingers well enough. And that's another thing you'll come to find as you work on antique radios, is that the controls back then are not quite the same as the controls now. Particular Philco, the control shafts have a little bit shaved off. They're not half moon, they're not fully round, there's like 10% shaved off. So modern half moon controls won't work, the knobs will fall off. But if you get a fully round one, you can simply file some of it down and it'll work just fine. We also have to cut the length of this down if we were going to use it to match. Why do I want to use a vintage control if I can? These are made really well. These are Type J Allen Bradley. I think they're mil spec. These are really quality controls. Modern controls, unless you spend a lot of money, they're kind of cheap and flimsy. Now the AVC is not working correctly in this radio. I'd like to remedy that next. The AVC works by basically sampling the incoming detected signal, low-pass filtering it to get an average, and use that as a bias on tubes. And how does it do that? Well, it uses a capacitor. It uses a capacitor to build up charge and act as a low-pass filter. It's generally a fairly large value. 0.1 microfarad, maybe half a microfarad, maybe even one microfarad. So it's probably in one of these boxes, because these are the larger value caps. See, there's 3 little wires coming out of this one, and I believe 3 little wires coming out of this one. The body is grounds. There's 3 caps in here, 3 caps in here. Let's take a look at the schematic. I do believe that is our AVC circuit. We've got a 1/2 meg resistor, and it's hard to read that. That could be a 0.05 microfarad cap, or that could be a 0.5 microfarad cap. Let's see, what does that resistor go to? Over, up, and it goes to the detector rectifier. So yeah, that has got to be, that's the low-pass filter. Resistor going to a cap to ground, that's a low-pass filter. And if we follow it up, there's a coil, and it goes over, and there's a grid on the RF amp. So that is going to provide bias for the RF amp. So it looks like that's the only tube that they tweaked the gain on for the AVC. So I don't know how well it works. I'm more used to working on TVs, and sometimes there'll be 2 or 3 tubes that are getting the AVC or AGC signal. So we need to figure out what cap that is. So it's 35. I need to get out my original Philco service info and see what is cap 35. Well, it turns out I was wrong, and that's a good thing, because it's easier to get at. It's this guy right here. And it is a 0.05 microfarad. And while you're going down over here, this is where the detector circuit is, and the 1/2 meg resistor, I think, is either that guy or maybe that guy down there. So let's rebuild that block. Alright, let's try our new technique and see how quickly we can take care of this one. So we're going to unmount it. We're going to cut the cap lead inside, or in the little eyelets. There goes the washer. There we go. And I'm not even going to heat it up. I'm just going to try poking this out. Maybe not. Alright, let's get the heat done. The others came out so easily, I thought I might get lucky. But nope. Oh, that one's really stubborn. More heat. Let's see if we can see it from the other side. There's a lot of tar on this guy. Seemed like the bigger ones that had 2 caps inside came out much easier. There we go. And there it is. Yeah, you know, from now on, so when I first started heating it up, I was heating it up from this side. There's only no tar there. It's when I flipped it around and heated it up from the back, I got to this. You can see how obviously it didn't get very warm, but you just need a little bit of heat to kind of soften things up a little bit. So if you can twist it around, it seems like heating it up from the back side is far more effective. Alright, so I just got to go dig up a new cap and proceed. Here's my new capacitor. I'm going to do a whole breakaway segment to discuss what kind of parts to use and where you can get them. For now, I'll just say this is a Panasonic polyester film 0.047 microfarad cap rated for 630 volts. It'll work just fine. Just need to manipulate the leads a little bit. Get the spacing right, just eyeball it. That'll do. And stick it through the holes on the back side. You can see that there. And get my trusty needle nose and wrap them around. I know I didn't even bother taking out the old leads, but you know what, I'm going to at least get some of the solder off so I have a little more to work. Alright, now I can get that on. That one's good. Let's get this guy. And we are good. Let's throw on some more solder. And then trim off the excess, and we are done. Well, not quite done. I gotta fish around and find out where the heck that washer went that fell out. And remount this, and then we are done. And I'm gonna go ahead and tack in one of those other potentiometers so we can check out two things at once. One, see if the volume control works any better with a different control, and see if we have some AVC action now. Alright, let's see if that new AVC cap makes a difference. I've recorded basically all of these sound checks, power-up tests at about the same time of day, so that's a good thing. So here we are again about 4:30 in the afternoon. AM transmitters often change their power levels in the evening, so I think it's a good thing that we're doing these all at the same time. Alright, so volume control all the way down. So clearly we still have issues. It's not the control that's the problem here. There's got to be audio leaking through. Alright, so here's the deal. I want to tune around the dial and see are most of the stations about the same volume without me having to touch anything. So let's start around AM 670. That's a strongish station. Alright, about normal listening level. About the same volume. Excellent. 780 WBBM, about the same volume.
Isaac, you want to weigh in?
WCPT, about the same volume. That's a local. That's the closest transmitter to me. I think that one is usually booming. It is louder than the others, but it's not like it was before.
Also, Edmunds allows you to search by color, model.
Not sure what that is. 890, probably. This seems to have made quite a difference. All the strong stations around me are now about the same volume, whereas before I was constantly adjusting the volume control. Now I'm now entering the section where they were really weak before, and I had the volume up quite a bit to listen to them. Yeah, they're a little bit quieter, but certainly listenable without me having to do anything. Oh, yeah, that made a huge difference. Excellent. And things kind of peter out down around this end. Well, that's to be expected. Now, for the big mystery. Why can't we get the volume to go down any lower than this? So let's just go for broke, and we're going to ground the wiper on the volume control to make sure that it's nothing to do with the control. Make it louder, but it's as low as we can go. Alright, let's try grounding the center wiper on that volume control, which should kill all sound from coming through. Here we go. Nothing. How do we know that it's doing anything? Well, turn the volume up. Nothing's happening. I'll disconnect it. Oh yeah, much louder. So that is grounded. So what the heck is going on? Well, let's look at the schematic. Here's the volume control. We are grounding this. We are grounding the grid on what they call the detector amplifier. So there should be no signal coming through to the first audio or second audio frequency amplifier or the speaker. So how is it getting through? Well, let's take a step back. This design is a little bit odd because there's no, well, specific diode rectifier tube. There's a bunch of triodes. What they're doing is they're using a triode 27 as a diode. So there's our detector that turns the IF AM modulated intermediate frequency into audio. So we've got audio at this point, and this control should be varying from one end of that resistor to ground, varying the volume. We've grounded this. So this is out of the circuit. How is sound getting through? Well, it must be leaking through somewheres in this stuff into this tube. Well, we can verify that. Let's find the grid on the first audio frequency amp and ground that. If that kills the sound, then we know somehow sound is bypassing this and getting around somehow to the grid of that tube. Now, I've already done a little bit of poking around. Let's talk about resistors for a moment. These things are what's known as dog bone resistors. If you worked in electronics before, I'm sure you're used to a modern resistor which has stripes on it. And there's a color code. And that tells you what the value is. Well, this is an early style resistor. And they also use the same color code, but the markings are different. They use the BED, the bed system, body, end, dot. So the body is one color, then the end of the resistor will be another color, and will be a dot. So a little hard to see on this one. Let's rotate this chassis a little. So red, and there's a green on this end, and then an orange dot. So red is 2, green is 5, orange is 3 zeros, the third is the multiplier. So 25000. It's a 25,000 ohm or 25 kilo ohm resistor. Okay, so notice there are no pin numbers on the schematic. So without digging into a tube data book and tracing out wiring, how can we find this point? Well, what's going to it? You see there's a 0.24 meg resistor, also known as 240K, which goes to another 240K resistor. Well, let's look around on here for a couple 240K resistors. So 2 is red, 4 is yellow, and then it'll have a yellow dot for 4 zeros. Well, we've got 2 right here. These are both 25K, and that one's green, these are yellow. So these are the only ones I see, and indeed one end of each are connected together. So it's the only situation I see on that schematic where you've got 2 of the same value resistors tied together that are 240 kilo ohms. So that's that junction. So we want to find the end of one of those resistors that's going to a tube socket. The other one goes to B+. Well, if we poke around and look at this end, there's a wire that's traveling down to a tube socket right here. That's got to be the grid on that 27 tube just by process of elimination. So let's try grounding that and see what happens. Get back on the station. So we have sound. I'll go to a louder station. There will be no mistake. We have sound. Let's ground that point. We have no sound. Great. So we know that somehow the sound is leaking into that point. Now there are a number of components around here, which is in this area. And what's going on there? That's where there are old repairs. That's where some funny business is going on. In particular, on this one, that's where there's an external capacitor strapped across an internal capacitor. Now, if that internal capacitor is leaky, as old paper caps tend to be, putting an external cap is not going to do you much good. It's still going to be leaky. Which means, well, I was going to say a signal can get through, but of course a signal, AC signal, can get through a cap too. So that doesn't necessarily mean anything, but just the fact that stuff has happened in this area. Old repairs. And also this one where they cut off a lug and there's stuff connected in space. Like a wire going here between two resistors. I have not traced this out. I think it'd be a good time to do that. I can get a highlighter and mark stuff off on the schematic as I verify it's connected properly. I want to cut these out and rebuild them as well. So I'm going to start with this one. I'm going to do a cursory checking of the connections, and then let's rebuild this block. There, well, you know, I was going to say there's two caps inside. I don't think so. I think there's just one cap between these two, and this is just a tie point because I do not see any little wires coming up onto that third lug. Down here, let me turn this off. I don't see any little wire coming up there, so I don't think there's anything going to that internally. It's just between these two. Now, if you're wondering, yes, there is an online guide that shows you the internals of every Bakelite block ever made. There's a part number on all of these. If I'm unsure at all about what's supposed to be in here, I can look it up online. It'll tell me exactly what capacitor values there are inside and what lugs they go to. There are some surprises. Occasionally there's an unused lug. Even less commonly, there's a resistor inside. I don't think we've got any of those. So let's take a look at this guy inside. One thing I need to mention too is that there is a note on the Philco forum about the Philco 90 service info for the version of the chassis that I have, that there's a mistake in the schematic. I don't know that if the schematic has the correction or not, and it has to do with what's inside these metal boxes. And it also turns out that some of the caps in this area we're talking about are in one of those metal boxes. This number 30, this number 30. Notice they both have the same part number. It's because there are multiple caps inside of one enclosure. And think about it. We have multiple caps in this box. If they're leaky, the audio signal could go from one to the other and find its way through there, is what I'm thinking is a possibility. Because, check this out. So we know if we ground here, the sound gets cut out. Imagine if a signal is getting coupled into this cap from elsewhere in the set. Find its way up through here, bypassing the volume control. Now I can see there's another cap here, and that's downwind of this one, so I don't think that would be an issue. But there are 3 wires going to that cap, so there's a third one, I'm pretty sure, Oh yeah, it's down here. Well, what's that going to? Let's go into what's that? The suppressor on the 24 IF tube. Could a signal leak its way through here and into one of these caps and up through there? Maybe. Now, I don't want to rebuild these boxes just yet, but I can clip the wires out going to them and tack in replacement caps. So what we're going to do is one at a time until we find the issue. This one actually I don't think is a potential problem, because that is not really involved in this circuit. Let's see, that is number 28. 28. Yeah, that's down. That's coupling to the audio output tube. So, yeah, that, I mean, we know the issue is back further, so I don't think that's it. But 23. Let's do that one first. I think that might be a guy in the middle. Again, the parts locator so handy. 23. Yes, this. 23. And notice the orientation's different too. So in the parts locator they show 23. Bakelite block is being completely vertical, and this one's at a pretty severe angle. So I wonder if in the, well, one, I wonder if this parts locator is just not that accurate. Two, I wonder, while somebody worked on this, did things get moved around? And I bet it did, because look at this red resistor here and this lead on it. That's coming pretty darn close. I'll zoom in for you. Here, that doesn't look right to me. That component lead's getting awfully close to that. And they show this as being mounted vertically. Let's see if we can loosen that nut up a bit and rotate the whole thing around. Now there's too much tension on this stuff. Boy, that doesn't, I don't think they would leave the, well, I mean, who's to say what happened back in the day in the factory? They might have gotten a little sloppy. But that doesn't look right to me. Also, obviously, these two resistors look different than the others, but there are one or two other metal capped ones, so I think just because there's a mix doesn't necessarily mean that they're replacements. But that does look odd. And of course, since somebody worked in this area, everything is suspect. I will try to manipulate things. The reason I can't move it is this resistor, the leads are at their full extent, and it's going to a lug on this cap. Hello, let's see, how do they show the orientation on that one? They show that as being cranked over this way too, so maybe, there, let's loosen that one, and loosen this one. Let's see if we can move them both. There we go. It's supposed to be something more like this. Yeah, the radio's turned off. Now that matches the parts locator quite a bit better. Alright, let's finally clean up this mess. Components attached to it are correct. It's this that was added, and this used to go there. This is pretty chipped up. When they cut this off, they must have done a pretty crude job. That goes to nothing internally. It's just a tie point for some other stuff, but it does make it a bit challenging to remove this and rotate it. Also, there's a bunch of crud, they wrapped a bunch of leads and junk around that. So I'm thinking I'm going to cut out and replace that resistor, because I bet it's also pretty darn far off. These are carbon composition resistors, which are notorious for drifting high in value over time. And these are really, really early ones, so it's probably drifted off quite a bit. So that's supposed to be 240K. And actually not as bad as I thought it might be. 285. In fact, that's close enough. Maybe we'll reuse it. But I do want to get that those extra leads that were wrapped around there off. Where to start? So I want to use that technique of doing it in place, but with so much stuff attached to this, I know I can't really move it too well. This resistor is pretty heavy leads and it's not very mobile, plus we got this stuff attached here too. What to do? Well, I'll try to take this off without destroying it. I'm going to see if I can get lucky just by heating this up and grabbing the part and trying to unwrap it. Sometimes that works. No desoldering braid, no solder sucker, no tools, just the pressure, waiting for my iron to heat up. Another little trick, sometimes it may seem odd, but it helps to put some solder onto the tip. That helps conduct the heat when you put it on to the old joint. There we go. Here, I'll grab. You can see the end of that new part they'd put on there. Let's get that off. It's kind of holding things up. Oh, well, I guess we are going to replace that resistor after all because the end just broke off, so much for that. And you know, I wonder, I was wondering if these were replacements or not. That does not look like a factory job to me. The end of this was just looped around once. For factory, they would have wrapped it around several times. Well, that decision's been made. And now you can see how these look inside. I've actually never really seen down inside one of these before. So it looks like it's a ceramic tube. And there must be like carbon granules or some such put inside. Let's see if anything... Well, nothing comes out. But I can see a shiny substance inside there. Let's see if we can kind of poke at it. Yeah, it's right up to the end. I assume that's like pencil lead, basically. Alright, well. And if we're going to replace that one, might as well replace this one too, because they're very tightly wound together. Alright, well. And see how that just broke off? I just moved it and it snapped off. I'm sure these were replaced. And I'll explain why they don't match this styling. Cleaning off a solder blob from some other old repair. Whoever soldered these on did not do a very good job. That also looks super crudely done. But in this case it was to our advantage. So now let's go to our new technique of we're going to twist away. And get this guy. This one's tough because that lug is bent over and there's a lot of chunk on it. Now let's work more on pulling that lug off before we proceed. This is why it's nice to get a pristine example of something that you want to restore, because you don't have to clean up crudely done old repairs. Now, as you see, as I start undoing stuff and disconnecting things, you can quickly run into trouble because I need to remember how to put all this back now. carefully bend this. Unfortunately, this cap is gone from my donor chassis, otherwise I would just grab that one, skip this one altogether. Also, there's quite a bit of the interior tire. It's kind of oozed out of this one. It's a good indication that there are problems with this one, or were problems in the past, and that's why I got replaced. Alright. I inserted a new cap into this block, reinstalled it, and hooked it back up. For the broken off terminal, I ended up just shoving the resistor lead into that eyelet. I have not checked this resistor value yet. I may very well end up replacing it. At some point I'll get back to this and make it neater. Once we get the whole radio functioning, I'll probably go back over everything and make it a little bit neater. Now, while examining this area, this kind of puzzled me because it does not quite match the parts placement diagram, which does to some extent show wiring. So right in the middle of our screen, that is that cap, and those three rectangular things are the resistors, and it seems like they show them all coming together on that side terminal. But on this, they all come together on this end terminal, which is contorted and twisted upwards. And the side terminal has one resistor, a wire going off somewhere, and then that new cap tacked onto it. However, I compared this to the schematic and it matches. Notice the internal component in this block goes to the top two terminals. The third one has nothing. That's just a tie point. So maybe there's another version of this block where the cap goes to the top, the outer eyelets, and the center one is used for a tie point. I don't know, but it does look like they had to kind of strain and stretch this one to make it work. They bent this terminal up. These resistors are kind of stretched to their limits in places. Who's to say? But I can tell you it does match the schematic. So these three resistors come together, and there's a wire snaking off going into this box. Now we'll power this up in a moment, but I do want to take an aside and talk about a couple things. Now, I warned you at the outset this was going to be a long, in-depth series. So we're going to talk about a lot of stuff. There's not going to be so much action. You see, as I'm recording this segment, I've already posted the first, and I'm starting to get some feedback. So that's why I wanted to address a few things. One, you've seen me poking my fingers all around underneath this chassis. There is a very real shock hazard, especially when it's turned on. We've got about 700 volts AC on the secondary of the power transformer and about 220 volts DC. The DC is what's really going to bite. The AC would bite, but the DC is worse. It's about enough, well, it's a lethal dose. If I was to grab this chassis with one hand and firmly grasp B+ with my other hand, that'd be going right through my chest. It could very well affect my heart. So be very careful when you're poking around under these chassis with the power turned on. And other devices, TVs especially, use much higher. 3, 4, 5, 600 volts are not uncommon. And of course there's a high voltage going to the picture tube. It could be tens of thousands of volts. All right, let's stick with this radio. Now when I turn it off, with all the tubes installed and the radio playing, the capacitors quickly discharge, meaning that after a few seconds, everything's kind of been drained away, and if I was to touch B+, I'm not going to get shocked. However, say I took some of the tubes out, like the output tube, and the speaker was disconnected. These caps would get charged up, and there'd be nowhere for it to go. There'd be no load. And after turning it off, for minutes later, there would still be a pretty good charge. Probably not lethal, but would certainly give you a jolt, which can send your hand flying, you bang into something, knock something over, you could hurt yourself or damage something, so be careful. You can discharge them, take an alligator clip to the chassis and touch it to B+. There'll probably be a little spark. If that concerns you, throw a resistor in series with your alligator clip, maybe 10K, 1K, something like that, which will take longer to discharge the cap, but you won't get that spark. Second topic. What are we trying to accomplish? Well, I know what I'm trying to accomplish, but more generally, when you're working on a radio, it's your radio. As far as I'm concerned, you can do whatever you want. You may see online, or you may get advice from other people about the right way to do it, or a certain way to do it, or you're doing it wrong. I don't care personally. The only thing I would stress is make it safe, like replacing that AC line bypass capacitor. As far as the rest of it, if you want to rip it all out, replace all the wiring with modern wiring, install terminal strips, drill holes in the chassis, I don't really care. It's your radio, do what you want. Make modifications, put an MP3 jack or Bluetooth, whatever. Have fun, it's a hobby. That being said, yes, there are some radios like a Xena Strat. There's one currently being auctioned or just finished, and it sold for $30,000. There's only, 50 known to exist, something like that. If you were to make major modifications, a lot of people would get bent out of shape about it, and you would seriously decrease the value of it to most collectors. I'm going to guess that most, if not all, my viewing audience does not have one and never will have a Strat, or one of the other super esoteric, rare, 5-figure radios. That being said, you're seeing me rebuild blocks and talk about preserving this and that. Why? Mixed bag. My opinion has changed over the years. Partly I use different techniques depending on my mood, or I kind of feel like if it's all original or nearly all original, it's just kind of nice to keep it as original as possible. So it matches the service info, and you can look at the parts locator, and it matches. And if somebody else gets this radio at some point, they'll understand what's going on. However, you've seen me, especially with TVs, relocate stuff to make things make more sense. So, for example, I mentioned these 3 resistors are coming together at this point, and there's this long wire snaking over to this box. Yeah, you could cut this wire off a modern cap. The value of the cap or the size of the cap that needs to go here is this big. And the other leg goes to ground. You could totally just put one side of it there and put the other side to a number of grounding points in the area. And just dispense with that altogether. Disconnect that box entirely. There's 3 caps in there. You could locate those 3 caps around the chassis and forget about it. Leave it in if you want for appearance sake, but take it out electrically. It would actually improve it, because having long wires run around like this, there's more chance to pick up noise and get crosstalk and interference. You can improve the design. So again, back, what do you want to accomplish? Do you want to keep it all original, warts and all? This is an early model, an early design. They improved it. There were 3 revisions just of this chassis. So yes, you can definitely improve it if you so desire. To some collectors, if that's your aim, to some collectors it's going to affect the value. Me just putting this jarringly new looking resistor in there is going to affect the value. To a lot of people, they just want the damn thing to work. Or they don't even care if it works. They just want to put it on a shelf in like a dentist's office or something. They'd say, hey, look at it. We were at a bar the other night, and they had a couple old radios there. They weren't working. One of them had been modified to hold various stuff, napkins and coasters and whatnot. It was purely for decoration. No, it wasn't a really valuable one, so no great loss there. But again, loss. I mean, who's to say whether it's a loss or a win? Totally up to you what you want to do. I'm just going through this and doing it the way that I feel like doing it on this radio. I do think it's worth rebuilding the blocks because it's pretty easy to do. And then it matches the service info, and you can figure out what's going on. Replace the electrolytics. Many folks do it like this. And they just leave them here, maybe put some more insulation around it to make it a little bit, decrease the chance of it shorting out. But you don't have to install new caps on the top or any of that. Now, I started out by saying I wanted to make this kind of an easy straightforward project, which is why I'm starting to tack stuff in. I do intend to go back and do the capacitors differently and whatnot. But for now, I just want to methodically go through and troubleshoot and try to fix problems as I go. So for example, this, I will disconnect this. I will tack a cap down in here just to see if we can eliminate various problems and learn a little bit along the way. Eventually, I do intend to rebuild this box and run the wiring as it was originally. But you don't have to do that, and we're not going to do it right now. I've also gotten several comments already about, why don't you just recap the whole damn thing? I mean, you know, so these problems you're encountering, like the volume control not working, that's because you haven't replaced all the caps yet. And, just get it done. Yeah, I have done that plenty of times before. No matter how I do it, somebody's always got another opinion. Yeah, these caps are all leaky. I can guarantee you that. They don't meet the specs of when this was made. But as we can hear, it is working remarkably well, I think, considering how many of the old caps are still in there. And I think it's interesting, at least now and then, to try going through methodically and doing repairs rather than restoring or rather than shotgunning it. That's the term that's commonly used. Now, if I was running a shop and I was getting paid by the hour and had a customer waiting for this, I wouldn't be making a video, I wouldn't be talking, I would blow through this. I could get this whole radio done and out the door in one afternoon, no problem. Doing it this way, it's going to take me a month probably, but I hope you all enjoy it and get something out of it. I'm learning plenty of myself, for example, about that capacitor being not just for line filtering, but to serve as the ground for the antenna. Of course, I mean, in hindsight, yeah, you've got to either ground the chassis to a really good ground or get that cap in there, or it's not going to work right. I hadn't really thought about it that fully before. And I haven't played around with substituting output transformers before either, so I hope we're all learning something as we go through this process. All right, I'll shut up now. I'm going to power this up and see what effect that had. Now that cap I just replaced is the coupling cap between those two 27s. I don't expect this to do much of anything. But it needed to get done at some point, and that area kind of bothered me, that the way that it was kind of hacked up. It is working the same as it was before. We still get the volume all the way down, but now we get some weird kind of motor boating humming between stations. That sounds fine when I'm on station. It could be something to do with the AVC. So here's another thought. It can get kind of frustrating when you're doing this one cap at a time. Things can get worse. You replace one cap, it can put a bigger strain on an already leaky cap and make it more leaky, so to speak. For example, we saw that the B plus has been low. As I maybe fix a circuit that brings it back up, it could cause other circuits to fail more. So it's not so straightforward, is what I'm getting at, when it's something this old, because a lot of the parts are suspect. Versus something newer where it could very well just be one part that's failed, you replace that, you're good to go. Anyway, what I'm going to do next is, let's try replacing, bypassing this guy, since we've just been talking about it and looking at it. Power it up, see what that does, and then after that we'll go after this one. Here's my new cap installed. I just left this wire hanging out here. Originally it was a 0.25, that's not a standard modern value. Instead I used a 0.22, that is close enough. grounding point. Use the same one I'm using for one of the power supply grounds. That's a strap going to the chassis right here, and the other goes to the tie point of all of those resistors. Let's see what that did for us.
Offensive linemen that can move people. They've got two really good running backs there.
Seems to be the same. I went through and reseated everything, tightened down the screw on this shield. Let's see if that did anything. Something else I noticed last time I powered it up. So we've got this in current mode, and that was up fairly high, over an amp, and then there was a crack, and then it dropped off. You may have heard that too. That sounds to me like a capacitor breaking down. So current's up, 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 up. Didn't get the power this time. There it is. It gets louder, and then the current dropped by 1/4 of an amp. And this problem is still present. I wonder if it could be interference, like from the lighting. Made no difference. Or the orientation or something.
Our daughter's division out, and two, how do we not capable of playing better in one-on-one situations? That's a general manager problem. Then he hasn't.
So this is one of the things where if you start getting a problem, go back and check what you last did. Well, this problem started when I worked on this. But I'm pretty darn sure I got everything right because there's not much to it. It's a cap inside. Replaced the resistor that broke. And we removed that one external cap and hooked everything back up. I'll check it again, but I'm pretty sure I got everything correct. In which case it might just be in nature of I need to replace a few other things. I don't want to waste a ton of time trying to track down a problem that will resolve itself when I get to some other caps. So everything checks out. I'm just going to move on to rebuilding this block.